Hi, and welcome to the third part of this tutorial on C# events. We have discussed that events can be triggered either by code logic or through a user's actions, for example, clicking a button. In the previous parts of this tutorial, we focused on events triggered by code logic. In this video, we'll focus on events triggered through user actions. So, in most of the tutorials provided by this channel regarding C#, the .NET Core Console App project template has been used as a starting point for creating the relevant sample code. This has been done deliberately so that we can focus on the language of C# and not be distracted by framework-related concepts. In this video, we'll do something a little bit different. We'll create a very basic code example, and we'll use the blank app Universal Windows project template to create the project responsible for the front-end functionality of our application. So we are going to develop a basic application using the UWP or Universal Windows Platform framework. This is so that we can look at how user actions, for example, a button click, can trigger events and how the relevant events can be handled appropriately in code. In this video, we'll show how a separation of concerns can be achieved whereby the front-end display functionality is loosely coupled with the back-end functionality. Specifically, we'll look at how events can be implemented to achieve this. So, one of the advantages that can be achieved by separating concerns is we can have one team that specializes in front-end design working on the look and feel of the application, and the back-end functionality can be developed by a completely different team. These two concerns can evolve independently from one another and in parallel to one another. The integration of the relevant components at an appropriate time can become a relatively trivial task. We are going to show how this loose coupling effect is achieved through the appropriate use of an event. A design pattern that can be used to achieve this loose coupling of front-end and back-end components is called MVVM, which stands for Model-View-ViewModel. For more content on advanced C# concepts and much more, please consider subscribing and please ring the bell so that you can be notified of future content released from this channel. Another advantage of implementing the MVVM design pattern to achieve this loose coupling of components is we are able to easily port, for example, the backend functionality to other platforms. Let's say, for example, you have a particular app which is being distributed via the Microsoft Store. This app was written using the UWP framework. Let's say the app is selling really well. Marketing research tells us that there is a huge demand for this app to run on iOS and Android platforms. Time is a key factor in keeping the momentum of sales going for this application. So we want this app to be appropriated for iOS and Android platforms as soon as possible, so that the app can be distributed via Apple's App Store for the iOS implementation of the app, as well as Google Play for the Android implementation of the app. So, we know that we can use the Xamarin technology to create a cross-platform app for iOS and Android devices. So, if we have designed our app appropriately using the MVVM design pattern, the backend functionality that we have already created would not need to be recreated for the iOS and Android platforms. Please navigate to this URL for more information on Xamarin. A team specializing in Android and iOS front-end design could focus on the native front-end functionality for their respective platforms. Or the use of Xamarin Forms could also be utilized for the creation of the front-end design using XamL. We'll discuss XamL in a bit. The back-end code already created for the UWP version of the app can be reused for the Android and iOS apps created using the Xamarin technology. For more information on Xamarin Forms, please navigate to this URL. The appropriate use of the MVVM design pattern could make the integration of the front-end functionality with the back-end functionality a relatively trivial task. The details of MVVM are beyond the scope of this tutorial. Please navigate to this URL for more detailed information about MVVM. Model-View-ViewModel. UWP stands for Universal Windows Platform. So a UWP application can run on any Windows device that runs Windows 10 or Windows versions greater than version 10. Windows 11 is due to be released on July the 29th, 2020. These devices can include PC, tablet, Xbox, HoloLens, Surface Hub, and Internet of Things devices. So we are not going to go into depth regarding the Universal Windows Platform. UWP demands an entire course on its own. If you want to learn more about Universal Windows Platform, please navigate to this URL. But let's look at a very basic example of loosely coupling back-end functionality from front-end functionality using events on the Universal Windows Platform. So let's create a project based on the blank app Universal Windows project template. Let's name this project and solution Employee UWP App. So once we click the Create button, we are prompted with a dialog box where we are able to choose the minimum version and target version that our UWP application will support. So to aid us with our decision, let's click on the link labeled Which version should I choose?, which is available in the bottom left-hand corner of the relevant dialog box. So we are presented with a web page, and at the end of the first paragraph on the web page it states, projects using .NET Standard 2.0 must have a minimum version of build 16299 or later. So we are going to develop our backend functionality using .NET Standard 2.0. So let's choose version 16299 from the drop-down list labeled minimum version. Right, let's add a standard library project to our solution. And let's name it Employee Component. This library will contain our backend functionality. So firstly, let's reference our Employee Component project from our UWP project. So let's right-click the References node within our UWP project and add a reference to the Employee Component project. Okay, let's delete the class that has automatically been generated. Let's create a class that will serve as our view model, and let's name this class MVVM. As the name suggests, a view model represents the data that will be displayed to the user. Let's make this class a public class. Let's write code so this class implements the iNotifyPropertyChanged interface. We must include a directive to the system.componentModel namespace. The iNotifyPropertyChanged interface is a member of the system.componentModel namespace. So to do this, we can hover our mouse pointers over the red squiggly line, click Show Potential Fixes, and then click Using System.componentModel. This interface contains an event that is key to how we can achieve a loose coupling between the backend component and the UWP frontend component that we'll soon develop. So, to implement the iNotifyPropertyChanged interface, let's hover our mouse pointers over the iNotifyPropertyChanged text, which has a red squiggly line under it, and click Show Potential Fixes, and then let's click Implement Interface. Note that a public event named PropertyChanged, which is defined as the delegate type PropertyChanged event handler, is generated for us. This event will be raised to the front-end code when a relevant property value in this class is changed. This example is going to be simplistic so that we can focus on the core concepts of this video, namely how events can be used to achieve a loose coupling between front-end and back-end components. So let's create a read-write property named firstName, and let's create a private member variable named _firstName. Let's encapsulate the underscore first name private member variable within the first name property. And within the set accessor of the first name property, let's include code to raise the property changed event. So if the first name property is changed, we want to raise the property changed event, which will have the effect of notifying the front-end view presented to the user that the relevant field must be changed on the front-end display, so that the change in value of the property is presented to the user. And this is a key concept to understand. When the view model is changed, the event notifies the actual view presented to the user of the change, and the change is then reflected in the view presented to the user. So the view presented to the user is never directly changed, for example by referencing an element of the view presented to the user. The underlying view model, which is part of the backend code, is changed, and this change is propagated to the view presented to the user through the implementation of the property changed event. We'll demonstrate later on how the UWP front-end component subscribes to the property changed event to receive notifications when a relevant property value changes. Let's wrap the relevant functionality that raises the property changed event in a private method, and let's name this method notifyPropertyChanged. Notice that this method accepts a string argument which will contain the name of the property that is changed. So now, within the set accessor of the first name property, let's write code to call the notifyPropertyChanged private method for when the first name property is changed. And let's create auto-implemented properties for the other employee fields: ID, last name, annual salary, gender, and is manager. Let's create a class named employees. We are going to be storing the employee-view-model objects in a generic collection type called an observable collection. The observable collection type represents a dynamic data collection that provides notifications when items get added, removed, or when the whole list is refreshed. For more information about the Observable Collection class, please navigate to this URL. So firstly, let's include a directive to the system.collections.object model namespace. The generic Observable Collection class is a member of this namespace. This class will simply contain a method that returns a collection of employee records. Let's create a public method named getEmployees. We want this method to return a collection of employee data. So the getEmployees method returns an object of type Observable Collection. The Observable Collection is a generic collection type, and we are able to strongly type the collection with the employee-view-model type. So let's include code within this method that creates a new Observable Collection object and assign the relevant object reference to a variable named employees. Let's write code to return the employees object. And I've made up some employee data for our employee-view-model objects that we can add to the Observable Collection object we have named employees. So to save time, let's navigate to a GitHub repository where I have already uploaded the code for this tutorial. So please navigate to this URL. Let's select the relevant code that adds the employee data to the employees observable collection and appropriately paste it into our code editors. We could have written code to retrieve this data from a data source, like for example a SQL Server database. But in the interests of keeping this code sample simple, we are using mock data as a substitute. The Observable Collection object represents a dynamic data collection that provides notifications when items get added, removed, or when the whole list is refreshed. We are going to use our Observable Collection type, which is strongly typed to store objects of type employee-view-model, to bind our collection of employee-view-model objects to a list view that we'll create in our front-end design when we develop the UWP component. Okay, so let's develop our UWP component. So the user interface for a UWP application is created using a declarative markup language named XamL, which stands for Extensible Application Markup Language. We are not going to go into the details of XAML in this tutorial, but here's a basic explanation of what XAML is. In a UWP application, XAML is used to define UI elements, data bindings, events, and other features. XAML elements map directly to Common Language Runtime object instances, while XAML attributes map to Common Language Runtime properties and events on those objects. For more information on XAML, please navigate to the following URL. So as mentioned earlier, I have already uploaded the relevant code sample to GitHub. In the interests of time, let's copy the relevant XAML from GitHub, and then we'll paste the XAML code over the XAML currently in the mainpage.xaml file. Right, so let's navigate to this URL. Let's copy all the XAML code from this page to our clipboards. And let's paste the XAML code in our clipboards over the XAML code currently in our mainpage.xaml file. And if we look at the XAML code, here you can see a blue squiggly line under the code where we are binding a list view data template element to the employee view model type. The reason for the blue squiggly line is because we need to compile the employee component so that our UWP project is referencing the relevant latest compiled assembly. So let's compile the employee component. And the blue squiggly line goes away. Great. And we can also see a design view rendering of our XAML code. If we take another look at the XAML code, you can see that the data binding functionality in the first name field includes a mode attribute which is set to the value of one way. This is an important part of the functionality that allows changes to the first name property of our employee view model objects to be reflected in the relevant list view displayed to the user. So in our code example here, we are demonstrating one-way binding from the view model to the list view element of the view. Let's write the code in the code behind file named mainpage.xaml.cs. The code we are going to write here will enable the user to select an employee record from the list view that is created through the XAML code, which will contain a collection of employee records. The user will then be able to dynamically change the first name field for the selected employee record by typing the new first name value into a text box and clicking a button to confirm the change. Let's create a member variable named _employeesOC, which is of the Observable Collection generic collection type and is strongly typed with the employee view model type. Let's create a public field named ChangeFirstNameCommand. This is a public field and is defined as the XamlUICommand type. For more information on the XamlUICommand type, please navigate to this URL. Let's write the code in the constructor of the main page class. Let's create a new object of type employees. So let's take a quick look at the XAML code. And you can see here, we have a list view named employee list. And you can see that there is data binding markup to bind the fields in the list view named employee list to each of the fields defined in our employee view model type. So let's go back to the mainpage.xaml.cs class. And let's write code to bind the data stored in the _employeesOC observable collection object to the employee list view. Note that the item source property in the employee list view is set to the _employeesOC observable collection. So let's go back to the XAML code. Notice here we have a button named btn change first name. that contains an attribute named command. And this code is binding the btn change first name button to the public field named change first name command that we defined as the XamlUICommand type in the main page class. Also notice that the command parameter attribute includes code that binds to the employee list view element. So let's go back to the main page.xaml.cs class and let's create a new XamlUICommand object for the change first name command public field. And let's use the += operator to subscribe to the execute request event on the change first name command XamlUICommand object. So after we have typed the += operator, we can press the tab key and a method with the appropriate method signature is generated for us. So when the user clicks the button named btn change first name, the code in this method will be invoked. So let's write the code for this method. Firstly, let's write code to get a reference to the employee list view object. We can use the args.parameter property to get a reference to this object. We must typecast this object to the list view type. Then let's write code to check if an item in the list view has been selected. If an item has not been selected, the selected index property will be -1. So if this selected index property is not -1, we can use the relevant list view object's selected index property to index the underlying observable collection object. And we want to set the relevant item's employee first name field to whatever the user types in the relevant text box. If we look at the relevant XAML markup code, we can see that a text box element is included in our markup. This text box can be used to rename a selected employee's first name field to whatever the user types in the relevant text box. So let's run the code. So the employee list view is not populating. Let's investigate why this is occurring. Okay, so we haven't included the code to assign the relevant observable collection object named _employeeOC with a value returned by the employees class's getEmployees method. The getEmployees method populates the observable collection object with objects of the MVVM type and returns the relevant observable collection object to the calling code. So to fix the issue, let's write the code to assign the _employeeOC variable with a value returned by the employees.getEmployees method. Let's run the code again. Great! That has resolved the issue. We can see that our list view is populated with MVVM data. Okay, so let's select the third record, and in the text box here, let's type Bob, and then press the button that is wired up to our change first name command object. And let's repeat the same process for some of the other employee records. Great! We are now able to change the employee record's first name field on the front-end display by updating the underlying observable collection. Note that the code is not updating the employee list view object directly. When the relevant underlying observable collection is changed, an event notifies the employee list view object of this change, and the relevant changes are reflected on the front-end display. If we look at the change first name command _execute request method that gets invoked when the btn change first name button is clicked, we can see that the underlying observable collection object is changed and the employee list object is not directly changed. This highlights the decoupling of the UWP front-end component from the employee component, which is responsible for data handling and business rules. For example, when the first name field was changed for the third employee record, the PropertyChanged Event, which is a member of the iNotifyChanged property interface, was fired, signaling to the front end that there has been a change to the first name field in the relevant MVVM object, which must be reflected in the relevant list view front-end object. And just for fun, let's include code to make our application speak to the user. So I've already prepared the code that will make our application talk to us in the relevant GitHub repository. So let's navigate to this URL. Let's copy the SpeakAsync method to our clipboards and paste it into the mainpage.xaml.cs file. This method includes an asynchronous method call to the synthesized text-to-stream async method. In order to call the SpeakAsync method that we have just included within our code, we must appropriately include the async and await keywords. I'm also going to make a minor change in that I'm going to rename the _employee OC variable to _employees OC so that the code we have just created is consistent with the code in the relevant GitHub repository. Let's run the code.
Changing first name from Bill to Bob. Changing first name from Jamie to Don. Changing first name from Sally to Debbie.
Excellent. So to summarize, this code that we have just created shows how the iNotify-Changed interface and the generic Observable Collection can be implemented to loosely couple the front-end component from the relevant code within the back-end component. This loose coupling effect has many advantages, which can include reuse of components across disparate platforms. For example, let's say we have an initial application written to run on multiple Windows devices through the use of the appropriate UWP Project template, and then at a later stage, we decide that we want this application to run on iOS and Android platforms. The component responsible for the implementation of business rules and data handling written using the standard library project template can be easily ported to run on the Android and iOS platforms without the need to change the relevant code. We do not need to rewrite this code for the Android and iOS platforms. Separation of concerns allows separate teams to work independently from one another. For example, the front-end Xaml experts, or as the case may be, the Android and iOS front-end developers, could focus on the look and feel of the application and the user experience of the application, while not having to worry about the details of the business rules and the database handling functionality. A separate team that specializes in writing the business rules and database-related functionality can focus on this concern without worrying about the implementation detail of the front-end design. The front-end and back-end functionality can evolve independently from one another and in parallel to one another. The front-end and back-end components can then be seamlessly integrated with one another at an appropriate time. I hope you have enjoyed this tutorial on events raised through user actions in the context of a UWP application. UWP is a very powerful platform that can be used for creating rich user interfaces that can run on multiple Windows devices. Examples of related Windows-specific frameworks include WPF, or Windows Presentation Foundation, and WinForms. If you want to learn more about WPF, please navigate to this URL. And if you want to learn more about WinForms, please navigate to this URL. For more content on advanced C# concepts and much more, please consider subscribing and please ring the bell so that you'll be notified of new releases from this channel. If you feel you have gained value from viewing this video, please hit the like button and please feel free to share any of the videos released from this channel with anyone you feel may benefit from their content. As always, the code created in this video can be downloaded from GitHub. A link to the relevant repository has been included below in the description.
Thank you, and take care.
Chat to you soon.